Okay, so I don't know about everyone else, but I had a great weekend. I spent my Easter with my family. I have 20 cousins, 10 aunts and uncles, and one of my cousins is actually pregnant. And she's going to be having twins. And so far, 5 of my cousins have had babies, and they've all been girls. So we were really excited to see what the babies were going to be. And when she pulled her thing out, the twins are going to be girls. I like girls, but I would have wished for them. But anyway, so as I was thinking about gift wrapping paper to give, I saw this and I thought, you know, that design kind of looks kind of symmetrical, but doesn't look really reflective and doesn't look like it has rotation to it. But then I start to realize that if you just look at this flower and this ribbon baby girl, and you kind of just slide it up or slide it diagonally, it's kind of the exact same figure. So that kind of sliding is called translation symmetry. So, what I would like you to do is look at this Braille code and talk with a partner and try to see if any of the letters have any translation symmetry to it. If any of the letters look the same and just slide it to a different place. Try to do it pretty quick. Maybe we'll be caught. Alright, I know you might not have been able to see all the letters. Let's bring it together. I saw a couple people circling or underlining some letters that they thought had translation symmetry. So, can you please tell us which letters you thought had translation symmetry? Just pick one. One pair. F and J. So, you see there's 3 dots that are like there and 3 dots are here. Now, if you were to slide F over to J, does it look exactly the same? No, just shaking your head. What do you think, Jess? Why isn't it exactly the same? Oh, so you have to rotate it, so that's not translation symmetry. Anyone else find any translation symmetry in the Braille code? Yes?
C and E, you just slide it diagonally.
That is true, but unfortunately, for a figure to have translation symmetry, the original image and the translated image has to be moved and not change in size, shape, or orientation. So you're rotating it a little bit. I understand where you were going with that, but so that was good. Now, why do you think that the Braille code, there is nothing that looks exactly the same? Oh man, you guys are smart. Okay. So now I was going to give these out and have you work on it and see which ones were translation, which ones weren't. But just really quickly, which one of these look like it has translation symmetry? 2. Okay. Any other ones? 4. Okay. What about number 2? You guys are really participating for this end of the class. Man, you guys are good. Okay. Now, here comes the fun part. We're playing with stickers today. Okay, so what I would like you to do is place your sticker that I give to you on your sheet of paper. And you can place it anywhere you want. And then I would like you to write directions as to how you would want the person that is going to be getting your sheet of paper to write a translation image. So you're going to be using inches. So you might say, I want to move it 4 inches to the left, or 5 inches down, or 6 inches to the right. But remember that a piece of paper is only 8.5 by 11. So you want to place your sticker image in the right place so the person can make the translation image. So I'll pass out the stickers. Please share. Please share the stickers. Just real quick, just put a sticker on the sheet of paper and write directions as to how you want the person to translate the image. change sticker, and then write a direction. And then I was going to have everyone stand up and move around and go to the other side of the room, but once you write your directions, just give it to the person sitting next to you. Right, and then you could have put the star there. Oh, okay, all right. So he was using the incorrect units, but it's okay. It's okay. It's good. It's good. Oh, so you put your star there. So I see a lot of you were using one-step directions. Some of you use two-step directions, which is very, very good. I see some people also drew theirs, which was great. So I'm going to use Eric's example. I know I'm running short on time, but I use Eric's example. So his partner put his star right here, and then the directions were to move the star 2 inches straight downward and 3 inches to the right. And then he put his translation image in that position. So you see, he went 2 inches this way and then 3 inches that way. And then if we were to take these points of the star and kind of make a line to the other ones of the translation image, you can see that they're all parallel lines. So now, I know, again, I'm running short on time, so maybe I'm not going to be able to do this, but you'll see on this piece of paper, I was going to have you plot points and then gave you directions on making your new translation image. So you would plot the points and then make a triangle and then go down 8 units and then go across 2 units and then create a new triangle. Having a little trouble talking out with your partner, figure out where to start, what your plan should be. Why did you choose that one? Yeah, and then what about 9 things before? Where's that? Okay, I'm going to just ask
What?
Alright, I know class is pretty much over, so we'll just wrap it up. But basically, the end all is to notice that in order to make your new figure, you can take the x coordinates, and if they were going to go down, you would subtract them by 8. And if they were going to go to the right, you would add them by 2. And then you would be able to find your new figure, draw your new figure. And then you can make a rule, which is basically would be your translation figure would be x minus n, and then your translation y would be y plus n. So thank you for all your time.